Hi, I'd like you to consider this question. What do all of the following countries have in common? Burma, which is in Asia, Liberia, which is in Africa, and the United States of America. Does anybody know? These are the only three countries that still use what's called the imperial system of measurement, which was like the English system of measurement. All three of these are countries that were colonized by England, but even England has given up the empirical or English system and officially switched to the metric system or the international system of units. You might wonder, well, why switch? Think about that. Think of some things you've learned over the years. I know that when I was in second grade, I still remember my second grade teacher introducing the metric system, and she told us by the time we graduated from high school, we would have our height measured in meters. The distance to drive to Hershey Park would be measured in kilometers. That our weight would be in kilograms. That we would measure everything in the metric system. Why is the metric system? There's two main reasons. I mean, first of all, it's pretty easy to do conversions in the metric system. You have to learn a couple of prefixes, and that prefix represents a power of 10. And once you learn those, you can put any base unit in and use the same prefixes and do conversions. Whereas in the imperial system, like, I'm going to be honest, I don't know how many teaspoons are in a tablespoon or how many tablespoons are in a cup or how many cups are in a pint or, I don't know any of that. I have to look that up every time I'm cooking if I'm going to double or half a recipe or, it says to use 2 pints of something. And I'm thinking, well, I got a thing here that measures cups. I don't know. I don't know. I have to look that up. So, it's very easy to do conversions because everything is related by power of 10. And there's also the value in that, the rest of the world is using the metric system. And if we all use the metric system, then working with people around the world and interconversion and communication with their measurements and our measurements and talking and working on projects together, whether it be engineering or space flight, we're all using the same system of measurement. So it certainly simplifies things. So those are the only three countries that do not use the metric system. Here's the thing, even though you live in the United States, there are a couple things that have switched to metric, like maybe you run track and field or swimming. Those distances have switched to the metric. But in general, in daily life, we still measure things in miles. We, measure our gas by the gallon and buy our milk by the gallon. But by the end of this lesson, you should be able to identify the base and the derived units in the metric system and know the prefixes and their values and symbols. And the reason is that even though in your daily life you might measure volume in gallons, in science class, measurements are going to be in metric, which the base unit is a liter. And we're also going to work on converting measurements within the metric system using dimensional analysis that we had learned the other day. So let's get started. Okay. So first of all, it's the metric system's official name is the SI units, the International System of Units. Even though it's the international system, you might wonder, why is it SI? That's because it's in French, and that's where like the International Bureau is housed. It's Système International. So, International System of Units in English. SI is the abbreviation based on the French name. The base units are defined by an actual physical object, like at the International Bureau. They have objects that are, a certain length, a certain mass, and they define that unit using, for example, like a platinum rod that is a certain length. Derived units are derived by combining some of the base units. Speed, like meters per second, would be a combination of, length and time. Can't see that. Hold on. Yeah, we should be able to. Would be a combination of length and time, like meters per second. This one mystifies people sometimes about volume. And I want to show you why those are derived units. Let me get just a pen instead of a highlighter. So if you have a cube, and I will do my best here to draw a cube. I am not the best artist. That's actually pretty good for me. The cube has a width. Let's say its width is a centimeter. Has a length or a depth. Let's say it's a centimeter, and please ignore that random line. And it has a height. Let's say it's a centimeter. So to find the volume of a cube, it's length times width times height. Or since they're all the same, we can just cube the side. So the volume here is 1 centimeter cubed. And for an answer, we get a cubic centimeter. Okay. A cubic centimeter, is the same thing as a milliliter. 1 cubic centimeter is the same thing as a milliliter. Now, sometimes you'll hear people talk about cc's, especially in medicine. I think they'll often refer to, like, give them this many cc's of blah, 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 Well, cc is a cubic centimeter. Cubic centimeters are easy to use sometimes because we can measure, like, for example, the volume of a box by measuring its length, its width, and its height in centimeters. Okay. But then we often need to use milliliters, like in graduated cylinders or water displacement, like we'll use later on in this unit. We will be measuring volume in milliliters. And so it's really important to know that a cubic centimeter and a milliliter are the same thing, so that you can kind of go back and forth between them. Okay, that's very, very handy to know. Now, a liter is the same thing as a cubic decimeter. So if I have a cube, and we'll have to pretend that it's bigger. I can't draw it. Oops, I can't draw it that many times bigger. And let's say that each side is 10 centimeters. Okay, 10 centimeters is the same thing as a decimeter. Like, each side is really a decimeter, because 10 centimeters is the same as a decimeter. Now, if you did the volume in decimeters, right, that's 1 decimeter cubed. Well, what's that equal to? So go back and do the volume of the exact same cube, but do it in centimeters. 10 cubed is 1,000 cubic centimeters, which is the same as 1,000 milliliters. And we're going to learn later today, 1,000 milliliters is the same as a liter. So a decimeter cubed is the same thing as a liter. Both of these are just kind of handy to memorize. You don't have to, like, draw a cube to figure them out, but I wanted to show you where they came from. But these are handy pieces of information that will help you with problem solving and conversions as you go throughout the year. Now, these are the metric prefixes that we want you to know. Yes, there are more metric prefixes than this. Okay. We've got the base unit. Okay. Meters, liters, and grams will be the ones you use the most often. There are, of course, other base units. If you have 1/10 of a base unit, right? 10 to the negative 1 is the same as 1/10, or 1/10. That's called a deci. Like, if you have 1/10 of a meter, it's a decimeter. If you have 1/10 of a liter, it's a deciliter. If you have 1/10 of a gram, it's a decigram. If you have 1/100th of a meter, like 1/100, which is 0.01, you have a centimeter. If you have 1/100th of a gram, you have a centigram, and so on. This 1/1000th, right? 0.001, 1/1000. Now, notice here, as you're memorizing these, decicent and milli, that it's 1 power of 10, right? And then all of a sudden, this one, there's 6 powers of 10. Do you see that? And I got a little random line up there. So this is 6 powers right here. I don't know if you see that, because 10 to the negative 9. So there are other units in between there, like micro is 10 to the negative 6. Honestly, I don't know the other ones. But nano is 10 to the negative 9, and that's one that you're going to need to know later on in the year when we deal with the spectrum, because light and the wavelengths of light measured in nanometers. And then, of course, you can go the other direction where, like, you put 10 meters end to end, and if you had 10 to the 1 is the same as 10. If you have 10 meters, that's called a decameter. 10 to the 2, that's the same as 100. So 10 to the 2 is, a hectometer. If you have 10 to the 3, that's the same as 1,000. That's a kilometer. Now, if I had 10 to the 3 grams, that'd be a kilogram. If I have 10 to the 3 liters, that's a kiloliter, etc. And once again, notice these are all like a single power of 10, and that this one is different. This one, all of a sudden, is 3 powers. And it's 10 to the 6th instead of 10 to the 3rd. 10 to the 6th is a million. So I always tell my students, I think it's easy to memorize because mega millions. When they say mega million, they're really saying million million. So mega million is a million. Now, how's this one different from milli? Notice this one's capital and milli is small case. That's important. And then deci and deca are kind of alike, but deci is a D and deca is a DA. So what you want to know in each of these is how that individual unit is related to the base. For example, like this gives us a conversion then to use. We know that a hectometer is 10 to the second meters, or 100 meters. This gives us a conversion. You can see that I'm going to end up moving. A milliliter is 10 to the negative 3 liters, or 0.001 liters. Those equalities are things that we can then use in dimensional analysis to solve problems. Now, if one other thing before we move on, if you want to come up with some kind of little saying to help you memorize this, I know, so I know people have in the past come up with little sayings, like this one, like this is not the mega and the nana, but I do remember a teacher had something along the lines of like, kids hate doing my dumb, crazy metrics. If that can help you remember the order. Okay? So come up with some kind of saying, and that'll help you out with those. Now, in doing conversions, what you want to do is you want to use dimensional analysis, because I now get students who want to move the decimal, but sometimes you'll see when we do some harder problems where you'll have to have the conversion as part of a bigger problem, and you want to be able to do dimensional analysis. So, for example, if I have 5 liters, I get those little random lines. You guys know that by now from watching these. If I have 5 liters and I want to convert to milliliters, we learned in dimensional analysis, you put the label down here you want to get rid of, the label you want at the top. And on the last slide, we learned that a milliliter is 0.001 liters. So what we have to do is take 5 and divide by 0.001. Now our unit will divide out, and our answer is going to be in milliliters. And when you divide this, you're going to get 5,000 and a little random line again. You could put it in scientific notation too. That would be just fine. So try the next one. Maybe pause the slide and see if you can do this one on your own. So I set up the labels because I definitely want my milligrams to divide out. Now I got to fill my numbers in. Remember that a milligram is 1/1000th of a gram. We got another little random line there again. So I'm going to fix all these. So, and that was a 5. It was purple, but we'll go with blue. So here we have to take 25 times the 0.001, and we get 0.025 grams. If you put that in scientific notation, sorry about that. These are just touch screens to write on. You can put it in scientific notation, and that would be just fine as well. Now the last one, you might need more than one step. I find it easiest to do it in multiple steps. So we're starting with centimeters. I know how to convert from centimeters to meters, and then I also know how to convert from kilometers or meters to kilometers. So I've got to fill my numbers in to make sure the top and bottom of the factor are equal. A centimeter is 0.01 of a meter. A kilometer is 10 to the third meters, or 1,000 meters. And you can easily see through here how your labels divide out, and you're left with kilometers. And when you multiply by 0.01 and you divide by 1,000, you're going to get 0.1234375. Oops, I said 7. Or I said the 7. And my brain was already going on to the 5. If you put that in scientific notation, that would be 3.75 times 10 to the negative 5th, which is great. So you're going to get some problems where sometimes you might need only one step, and other times you might need 2. Here's 2 more sample problems, and then we'll be done. What if you have something like this? So 78 centimeters cubed. Sometimes people go, oh, centiliter. Look, this is a centimeter, not a centiliter. The first thing you have to do is get it into something that you can change to liters. Remember that we learned when I was drawing the cubes that a centimeter cubed is the same as a milliliter. And setting it up like this will allow us to divide out the centimeters cubed. Then we can have a conversion from milliliters to liters, where we know that a milliliter is 1/1000th of a liter. So 78 times 0.001, and you should get 0.078 liters. Or you could put that into scientific notation, 7.8 times 10 to the negative 2. Down here with the 4,200 decimeters cubed, again, you don't want to be looking at like deci to, don't want to be looking at deci to kilo, because this is a decimeter and that's a kiloliter. Can't compare them. And this is a decimeter cubed, which is the same as a liter. Then you can go from liters to kiloliters, and we know a kiloliter is 1,000 liters. You can see that your units are going to divide out the decimeters cubed and the liters. Our answer will be in kiloliters. Let's go back to the purple, one easier to see. And when you divide through, you're going to get 4.2 kiloliters. Okay? So these are examples, and you can certainly put these in your notebook or look back at them anytime, because you're going to need to be able to do conversions, okay, using dimensional analysis. So you want to know your metric prefixes, the values, and the symbols. You also got to know those derived units, that a centimeter cubed is equal to a milliliter, and that a decimeter cubed is equal to a liter. Those are both very important. Okay, good luck with your metric conversions.